So, beginning to develop this understanding of the structure of matter evolved from the sequence of 3 discoveries that are articulated as scientific laws. And we will see that the statement of a scientific law is extremely crucial because that law can be tested by observations. And as we'll see, these scientific laws, when we look at the changing way that science viewed matter, these laws were crucial to these changes in our conceptual understanding. And the first law that led to a new atomic theory of matter was formulated by Antoine Lavoisier in 1789, and he's often called the father of modern chemistry. And as we will see, he deserves all of the credit, and this designation as the father of modern chemistry is highly appropriate. So let's see what Lavoisier did. He was the first to isolate oxygen in 1778. Then he isolated hydrogen in 1783. But the thing that Lavoisier discovered that was so important was that mass is constant in a chemical reaction. And of course we take this for granted today, but this is the first time this idea was put forward. So the law in a chemical reaction that he defined was that matter is neither destroyed or produced in a chemical reaction. Therefore, writing this down directly, it meant that if we took the mass of the reactants in a chemical reaction, that always equaled the mass of the products of that chemical reaction. Or, if we take our favorite chemical reaction, which is A plus B going to C plus D, it meant that the mass of A plus B is equal to the mass of C plus D. Something we, of course, take for granted now, but this was a revolutionary change because it meant that the chemical transformations were telling us something very fundamental about the exchange that took place in that chemical reaction. So the crucial thing that Lavoisier brought to science was high accuracy measurements. And before the advent of high accuracy measurements, it wasn't possible to even ascertain what happened in a chemical reaction. But bringing high accuracy measurements of mass to the practice of chemistry profoundly contributed to the quantitative ability of chemists to analyze what was going on in a chemical reaction. Now, Lavoisier was a member of the French aristocracy, and tragically he was beheaded in the French Revolution in 1794. But his contribution to chemistry is forever etched in our understanding of atomic theory.